Hello everybody, this is Dr. Nur Badsha from University of Engineering and Technology, Peshawar. In this video, I'll be talking about interpolation. So before I proceed with the interpolation methods, I'll explain what do you mean by interpolation. Interpolation is basically the process of finding value of a function at a non-tabulated value of x by using given values. For example, if we are given a tabular form for something like for a function, values of x, corresponding value of function. If you are given values of x are 2, corresponding function value is 9. This is, let's suppose, 4. This is 19. If this is 6, this is 31. And let's suppose that is 8. That is 8, and then we have 56. So these are the given information, and we want to find value of this function f of x when x is something like 3. Now clearly you can see that the function is not defined explicitly, so it's not possible to find this value directly. So we have to go for interpolation process. You may be asked what's the value of this function when x is 5. You may be asked what's the value of this function when x is 7. In this case, you clearly see that the value of x are equally spaced because the difference between 2 and 4, that is 2, that is 2, and that is also 2. Sometimes we can have the value of x unequally spaced as well. The value of x is something like maybe 1, 3, 4, 6, 7, and the value of y or f of x, that could be something like 9, 13, 25, 36, and maybe 79. And you are asked what is the value of this function when x is 5. What would be f of 5? What would be f of 6.5? Or what can be f of 2? So we usually classify interpolation method into two groups. One is known as interpolation of equally spaced data, and the other one is interpolation of unequally spaced data. In this video, our main focus will be on interpolation of equally spaced data, in which I'll be talking about first formula used for interpolation, which is known as Newton forward difference formula. Utilization of this formula, when do we use this formula for the given data? The first step is the value of x that should be equally spaced. We cannot apply this method for unequally spaced. So let's suppose the points are 2, 3, 4, 5, 6, and corresponding function values are something like that. Any value it could be. Now, if you are asked to find the value of function when x, that is what? That is 2.5. We sometimes label this x as xp, where xp, because they are equally spaced, so in case of equally spaced, we can express, if you call this one as x naught, if this is x1, this is x2, x3, x4. So because the data or the values of x are equally spaced, so we can express x1 as x naught plus h, where h will be the common difference or the step length. X2, that would be written as x naught plus 2h, x3, which will be x naught plus 3h specifically or generally for any value of x, xp, we may call that x as well. X is equal to xp, that will be x naught plus ph. So if this unknown value or the value of x for which we want the value of function, if you are interested to find f of x or f of xp, so if xp, if that is at the top of the data, I'm defining top in this way. If you are taking the values of x, like in this case, y are these. So we have, let's suppose 2, 3, 4, 5, 6, something like that. So if the unknown value is between 2 and 3, let's suppose here somewhere, it could be 2.2, it could be 2.3 or something like that. So the most suitable formula will be this Newton forward difference formula. We may call that Newton-Gregory difference formula as well. So for a given value of x, how do we define or how do we derive this formula? So let's suppose we are given x naught, f naught, x1, f1, x2, f2 up to xn, fn. If these are n plus 1 equally spaced data points, sorry, this is not n, this is n plus 1, because we are starting from uh, x naught and going up to n, so there are n plus 1 equally spaced data points for the given function f of x. Okay, and we want to find the value of this function f of x at a point x, which may be labeled as xp, or we can call that x naught plus ph. So the formula for this function or for interpolation polynomial for this will be given as like this. We have fp, that is f naught plus p del f naught plus p into p minus 1 by 2 factorial del square f naught and so on. We are having n plus 1 equally spaced data points, so the polynomial will be an interpolating polynomial based on Newton forward difference formula will be of degree n. So how can you prove this? So let me prove this for you as well. Okay, so how can we do that? We want to find fp, where fp can be written as f0 plus p. Now we have an operator that is known as shift operator, and when it is applied on a function fr, that basically shift that from fr to fr plus 1. The second order, we denote that by e square, so e square fr, that basically means shift that to r plus 2th position. In similar way, if we want to find shift operator applied p times on fr, that will give you fr plus p. So using same concept here, if we take r equal to 0, what would happen? We have f0 plus p, and that would become e power p and then f naught. So we may write this one as this f0 plus p is e p and then we have f naught. Now there is a relation between shift operator and a forward difference operator, that is e is equal to 1 plus del power p f naught, because del, when del is applied on fr, that gives us fr plus 1 minus fr, so that is basically e fr minus fr which might be written in the form E minus 1 FR, which implies del is equal to E minus 1 or E is equal to 1 plus del. Now, using binomial series to get this expansion, so we have 1 plus P del plus P minus 1 divided by 2 factorial del square and so on. We will be taking up to n plus 1 terms, and that is applied on f naught. And then this will lead us to what this operator, it's a linear combination of this one operator del square and so on. So when it's applied on f naught, we get f naught plus p del f naught plus p into p minus 1 divided by 2 factorial del square f naught and so on. This is known as Newton forward difference formula. Keeping in mind that the value of p that will be found is, we see that x is equal to xp equals x naught plus ph, where h is obviously the common difference. Then we can find p is equal to xp minus x naught divided by h. We may restrict or we may impose a condition on p that p will be between 0 and 1. Sometimes we do that. P is between 0 and 1. That would mean if x is between any two values, let's suppose we have values of x, the values of f, so we have suppose 1, 2, 3 and so on, the same function values as well. If you want to find a value of function between 1 and 2, that is xp is there, so in that case x naught will be chosen as 1 if you want to impose this condition p between 0 and 1. If the unknown value is between 2 and 3, in that case 2 will be taken as rx naught and so on. That's the procedure we'll be following because we want to impose the condition p is between 0 and 1. And that's not a must condition for it. Sometimes we do take p between minus 1 and 1. Sometime we can maybe keep the value of p free of that condition and we can have any value of p. So let me do an example by how do we do that by using calculator. So let's do that. Let me open calculator as well. Okay, so I'll explain this method. The first step is what? You will construct the difference table. We are given the values of x. The values of x are 0, 1, 2, 3. These are the values, the labeling. There are 4 values. The values of x are 0.5, 0.6, 0.7, 0.8. Right, so these are equally spaced. The first step is you need to check whether it's equally spaced or not. And these are the values of the function cos hyperbolic x. The function may or may not be defined explicitly. So in this case, our interest will be only in the values of the function 1.127, 626, and so on. You know how to construct the difference table. If you don't know how to construct a difference table by using calculator, please watch my video on constructing difference table by using calculator. I may share a link of that video in the description. So you would first construct the difference table by using calculator. Once you have done that, so we want to find the value of function at x equal to 0.56. 0.56 that is between 0.5 and 0.6. it means we will be choosing x naught to be 0.5. H, that is what? That is zero point 0.1, because zero point 0.6 minus zero point 0.5, that is 0.1, 0.7 minus 0.6, that is 0.1 as well. So H in this case is what? That is zero point 0.1. The value of P, as I explained in the previous slide, that P is equal to xp minus x naught divided by H. So if you put xp, that is 0.56, and x naught is 0.5, so we get 0.06 dividing by 0.1, that would give you 0.6. So P is what? That is 0.6. Now computing these values one by one and then adding them together, multiplying them together, it might be time consuming. So what we can do, we can use calculator for it. So I'll be using A, B, C, and D. You should construct difference table by using that calculator as well. So if you know how to do that, it's better. If you don't know, watch my video. So what would I do? I will simply call this one as my A, this one my B, this one my C, and then D, whereas I'll call my P as X, and then I'll just put the value of X one time, and that will give me the final answer. So the first step is you have to convert the mode of calculator to math mode. That is pressing mode button and then press 1 to get to that math mode. So what do? We first go for, that's the formula, we have f naught. So f naught, as I said, I'll call that as A. So A is my f naught. Then we go for plus, then we have P into del f naught. So I'll just write X multiply by B. The third step is what? That is P into P minus 1 divided by 2. So I'll just give that. So it's X, and then I'll write X minus 1 divided by 2, and then we have multiplied by C. C is my second order difference. This is A, this is B, this is my C. And then we have another term as well, which will be X minus 1 that's X minus 1. Then we have X minus 2 close the bracket, and then we have 3 factorial. So we can write 6 or we can write 3 factorial as well. Factorial is here, so that will be taken with shift. So that's 3 factorial. And then multiplied by what? Multiplied by, have used A, B, C, and then we have now D. So I'll just write D here. So we are going up to third order. So you see this is third order difference, then previous one was second order, then we had a first order and the value of function. So as you press this calc key, what would happen? It will ask about the corresponding values. So you'll just put these values in directly. So I'll just press calc, it asks about the value of A. The value of A is what? That is 1.127626. So just give this value and then press equal. It will ask about X. So our X is 0.6. So just give it this value once and it will use it again and again by itself. B is the first order difference, so that is 0.057839. Press equal, then it will ask about a second order difference, which is 0.011865. Press equal, it will ask about the third order difference, which is 0.000697. You are all done, and just press equal to get the final result. That will be directly 1.160944. So you see that if you're doing that one by one step, putting the one value and then plus 0.6 into this one, then you are doing for 0.6 and 0.6 minus 1, 0.6 minus 1, 0.6 minus 2. So obviously it will be time consuming, so it's better to do what? You can directly put the value in it, and then obviously you will get the final value. In this case, obviously, if you're changing the value of x between 0 and 1, mean to say zero point 0.5 and zero point 0.6, so you'll be using same value. The only difference will be coming in x. For example, if you want to find the value at 0.57 or 0.59 or 0.51, what would you do? You would simply find this p again and just replace the value of x. You don't need to change the value of a, b, c, d. But if you change the value to zero point 0.6 and between zero point 0.6 and zero point 0.7, obviously you'll be changing the value of a, b, c, d as well, because in that case this will become a, this will become b, and this will become c, because your x naught will then be zero point 0.6 if the value is between zero point 0.6 and zero point 0.7. If you take something like 0.65 or 0.66 or 0.63 or something like that. So that's what we've done. So that's the final value. And then thank you very much. See you in next video. If you have any question, drop a message in the text box and I'll get back to you. Subscribe to my channel and please share the video with your friends. Thank you.